So the question was, if I'm not mistaken, the question is, how come we're sort of like operating with this at this two decimal points?
Right.
Okay, no, that's completely our choice. So I'm going to say no to exit program nicely. And if I go back to my source code, this is where I set this precision. So I could change it to 4, right? I could change it to 4. Then if I rerun this program, and if I type something like this, 100 point 1, 2, 3, 4, 5, 6, 7, something like that, what I get is then the big decimal begins rounding at 4 fractional numbers, right? Because I just bumped up the precision, changing it from 2 to 4, right? So
would it be, in terms of keeping track of the money, would it, do you lose anything if you just use the 2 as opposed to 3? In other words,
yes, the question is, what is your choice when you try to program? How do you know what level of rounding to keep, like what precision to use?
Right.
When you do, what's your choice? How do you make a decision whether to use four digits or 2 digits? The answer is the banker will give you a in set of instructions or functional specification. They need to discuss it. They need to use like little calculator to decide what they want to use, and we need to interpret their input and translate it to our instructions. We may ask them questions. What level of precision would you like to keep attempting this computation? What rounding mode you want? And they will tell us, and we'll write the code.
I agree with all that,
Mm-hmm.
and I agree that that's their choice. But
Mm-hmm.
what I was wondering is, do you happen to know offhand, for instance, if it's two digits,
Mm-hmm.
or rounding on the third digit,
Mm-hmm.
do they lose money or do they gain money, or
It's a good question. Like what experience shows.
Right.
Typically, a very typical precision that is used very commonly, 6 digits. Very typical level of precision, 6 digits after the decimal point in many computations. Like when they compute our payrolls, most likely they use 6 digits precision to come up with cents eventually. Basically eventually rounding before the checks are printed to 2 decimal points in the end, which will show up on the check. Something like that. You're welcome. Okay, so that is sort of like a look and feel for big decimal and what you can do with it. Another example which I definitely want to jump to today is here. If I just scroll up to let me just do it quickly, Java samples which are posted here. So floating point rounding and precision, this rounding .java program is just the one that we just used. The second one, big decimal math, is here. Basically, the argument is that now that you have big decimal alternative to the double or float primitive data type, because now you can control the rounding, which may be taking place not necessarily at the level of us rounding the number, but also the precision that we may actually lose as a result of doing computations, such as multiplication and division. Right? So multiplication and division will result in those crazy fractions which have to be observed by double or float or big decimal. And in case of big decimal, we have control at the level of precision at which those things will be taking place. A very important example, so let's just kind of slowly observe this from this example. Main method. So what it does, it says, okay, let's create a big decimal. And the big decimal is 1.0, something really kind of silly. Then we say, okay, so let's set the scale, right? Set the scale and use scale value, which was declared here as 4. 4 decimal point after the 4 digits after the decimal point. So we say this is precision 4, the scale value, otherwise known as precision. And we want to use rounding half up, which is the common, widely accepted method of rounding. That's okay, right? Then we say the divisor is 3. 1 divided by 3, as we know, it results in this. If you use your calculator, it's going to be like a runaway train, an endless fraction, which is 0.33333, and your calculator eventually will chop it off at the whatever level of precision is available. So in our case, let's try this. Let's try this. And copy and paste again. One of my favorite operations, I guess, whenever possible. Not true, but it's okay to copy and paste. Okay, so I'm going to erase this particular sample with a scanner and a while loop and replace it with this, just in case. It never hurts to say source format. And I forgot that I don't have a scale value. I will simply just use like integer scale value equals 4, as was used in the example. And then so let me follow on this a little more. So I'm using the value and the divisor. My plan is to divide 1 by 3. That's why I named them the value and the divisor. And the next thing that I'm going to say, divide. I'm just going to say divide. And as with set scale, you have to remember to take the value from the result of set scale. When you say divide, you need to capture the result as another big decimal. It's very boring and rudimentary level. You have to remember all this, but these are the rules of using big decimal. It's not our choice. We have this object. It has some useful functionality. We're going to use it, but we have to follow the rules. So when we say divide, it produces a brand new big decimal, which our responsibility is to capture it. So then there is this version of divide, simply which says, all right, let's grab this value and divide it by the divisor. If we run it, so save it and run it, I'm trying to run it. Where's my output? Right here. Oh, did I ever, you know what? Let me see. It's one of those glitches where I want to go back to my project and somehow it didn't recognize the change or didn't recompile. It's actually pretty frustrating sometimes. So I need to say clean and build. All right. Sometimes I'm surprised that NetBeans fails to recognize that the change was taking place and like runs the old program. I don't know where it's coming from, but it says running. Let me actually. All right, close it, and then again go to my project, clean and build. Perhaps the older version was running or whatever. Finish building, and then run it. So this time, the clean approach to this. Non-terminating decimal expansion. This is another name for this endless fraction, which is the result of an attempt of dividing 1 by 3. So, and you know, this actually this method does exist, and it produces another big decimal result. But when you program, you almost never use this version because there is no protection against this exception unless you want to capture that exception, and this will signal you that you have this endless fraction. All right. For most people, you just want to divide at this certain level of precision. And for that case, which is like 95% of cases, I suppose, you need to say divide, provide the scale value, and provide the rounding mode. So this time, hopefully, it will not complain about the fraction, but actually will be able to run it. And it says, all right, you wanted 3 significant digits after the fraction, which was our I'm sorry, not 3 but 4, 4 significant digits, which was our scale value used uniformly through this example, right? And so it did this, and the scale is 4, and this time there was no problem, executing this division. So this is the flavor of what is available with BigDecimal. We're covering it, and in many cases, in quite many cases, you can just sort of like say, I got it, and forget about it the next day. Simply because it's not that we kind of write this code every day. But this is just a general idea that those issues do exist. Those are important issues. And if you open any financial, non-trivial financial engine source code and take a look at it, you're going to see this business there all the time. It's going to be there. It's going to be part of it. Don't be surprised by it. Just the rules are very simple. In fact, after all, this big decimal allows you to add, subtract, divide, and multiply. Okay, and that's all that we have to be aware of. Other cases, multiplication, addition, and subtraction will not produce this error. So there is no need to worry about that part. But with divide method, you really have to be aware of it.